Here we go. Uh, ah! Ah! It works! Okay, 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 okay. It might be that we have some remains of Sion's chat in on screen right now. Oh wow, there is a lot of TTS happening right now. 2 kilowatts? No, it's wrong. It's 3 kilowatts. This is this this is the power supply. This, this is the power supply. 3 kilowatts. Here we go. I'm trying to figure out how to get, like, this is the today's topic, to try to get the proper power conversion from 12 to so here, this is the PSU. Oops. 3 neck warmer. Yeah, pure copper here, pure copper. Yeah, you need to help me with the connectors. I can't find information on some of those. The old ones. I will show you which. So this here is in production. At least, oh yeah, there's the clear filter. I think I only made one mistake in the order. Let me check that, just to be sure. 20, yeah. I let the 22 picofarads, I put in 100 nanofarads instead. So the crystals on the row controllers won't work with the on the row controller won't work, but they are running. We can run internal oscillator anyways, or I can swap them later if I like to. Anyways, yeah, slight mistake. I don't know if I want to fix that, or I can leave that oscillator unpopulated. So latest development. It took me so much effort to get the order in JC, and then they wanted like extra money for doing a whole panel. If I want the gold fingers, it seems they wanted like 200 euros extra because they need to process the whole panel, and since I only utilize a part of it and they need like to extra handle it, they want like 200 euros extra, and I had to cancel because I mixed the output files. When you use Altium, if you use plain layers instead of signal layers, I switched from signal to plain, then they are renamed, and the zip file that I sent to JC still contained the signal layers, which were from a completely different design, like the old one. Thankfully, the JC dudes caught that mistake, and I had to, after 2 days of waiting and review whatever process at their side, I said, oh yeah, right, cancel it then. I could, they gave me the opportunity to re-upload some layers, but then the stack-up would be the wrong order, or I would like need to also, and I thought, oh, maybe I will just skip the thing with the gold fingers and everything, and get a cheaper order, and now it's like 400 bucks for 4 PCBs, populated PCBs, and one unpopulated one. So a lot of setup costs and whatnot. I hope when I order the big batch, that won't be as expensive. Otherwise, I will be It's 128 PCBs. So if 4 cost like 400, then you can imagine 40 cost 4,000, and then yeah, we're basically out of money before we even get the parts for that. Anyways, one thing, it took me like ages to upload the BOM file because in the column designator they only accept 2048 characters information for you. So you need to split, even though it's like the same part, you need to split it in different rows. You can do it here. I did it afterwards, so you can do operations, add alternative. Yeah, wait, need to put an original row here. This one, operations, and then you can do a split item, and then you can basically select individual checkboxes which items you want to put in a new row. So you can use like the same footprint and different values or whatever. I didn't split it by values. So when on Sunday when I tried to upload the BOM, that wouldn't work. So I used Gemini to Gemini write a script that would basically split each row, copy it and split it, so it wouldn't exceed the character limit. At least the homepage, the JC homepage, reported that that is the issue. Otherwise, I wouldn't know. Yeah, that was the good thing. Now the order is placed. The PCBs are reviewed and looking good, but the pick and place file isn't reviewed yet. I had to rotate. You know the preview that you get with JC assembly. Yeah, probably you don't know that, but let's see what the current state is. Hope I don't dox myself. No. Let me reload here. Maybe but it's after working hours for them. So I guess at 4 o'clock they will start again working. I determined that now. Data preparation. Yeah. So first they wanted like confirmation. Or I wanted confirmation, and that was good. I could review what the file here. Yeah, and the place file you can see the preview rendering. Do they show it? I don't get the rendering of the MCUs because they are co-signed. Only the big ones, and the big ones I had to rotate. They were wrong. So I needed to rotate them. So most probably the LEDs, surprisingly, the LEDs were right way around. I added even a marking, the marking that's underneath the PCB. That's correct. So LEDs, I didn't have like to rotate 512 LEDs, but the MCUs there is a placeholder. There is no rendering yet. I hope they will give me. I picked the option for. Confirmation of the production data, so I expect tomorrow morning to receive basically a rendering or a question via email if that's pin 1, but I have the marking for pin 1 on the little MCUs. I don't know if you can see there is a little dot in one of the corners, but the two rows are different way around, so it's like 180 degrees rotation. I hope we have to get that right. So let me greet you first. Hello Sonic, hello Cosine, hello Yombo, hello Dutch. Oh, hey Johnny. Yeah, that's the current state of that thing. Yeah, I opted for assembling four panels, so I won't waste like three panels, so it's quite risky, but I'm feeling more confident in the review process. So the first time I ordered, it was like really janky, everything was like barely working. So when I tried to upload like pick and place file and whatever, I got constantly errors because they are quite huge. And this time I know what the server wants, and I prepared the files correctly, except for the picofarad capacitors. Unfortunately, there will be nanofarads now. Yeah, that's not good. They won't run. Anyways, I can just knock them off. It might even run better without any capacitor at all. Yeah, we have our new soldering stations. We can try that if we like. Body hurts. Plastering and water damage. Oh, what? Still a hole. Plastering? Did you? Who pays for the pick and place? You mean like we buy a pick and place or what? I even thought about it. Yeah, I mean I ordered it placed, but I thought if JLC doesn't can't manage to place that, I will just make it. Hey 4-4. I'm on one. All right, so power distribution. Yeah, that's the issue. That's the thing that we need to talk about right now. Today's stream is about power, and obviously we can't run them off my new little power supplies. You show it here. No. I got your power. Oh, booster here. We can't run them off these power supplies here, even though they are quite cute and they are nice. How? Oh yeah, Murata. Yeah, that's basically Monmon. You caught my you totally have the same thoughts as I am. So I will show you my latest research. I'm on the Murata page, and oh wait, here I found these ones here. I think they are like 20. No, these are 12 amps, but I would need like 90 of those. 90. And they are 90 times 10. That's like $900 just for the conversion here. And where do you place 90? I mean, we can place them circularly around. There is like another. I'm a little bit confused about those here. They're like 50 amp modules. This one is discontinued, unfortunately, because that's like a plug-in thing. Maybe we can still get it somewhere. 500 euros for the conversion. Yeah, yeah, I expect. I mean, I would expect, since even the container costs 400 euros plus shipping, so probably more like 450 euros. Everything is so expensive at this scale. I thought like, okay, I'm about maybe 400 to 500 bucks for the conversion would be acceptable. But now, I mean, yeah, and we need like to distribute. This is so much. This is so much power. I don't know. That feels like it could be. I'm worried about the cooling, but the cooling is the last step. Let's do the conversion first. As soon as we got the power figured out. Oh yeah. There's one more thing. Of those two power supplies, which those two power supplies? Oh, the small ones, yeah. Because we need 900 amps. 900 amps in total. I will open the booster now. I had just a power nap, by the way. That's cute. 400 amps. And 900 amps. Yeah, 900 amps. That sounds dangerous. At 3 volts, it's like... That sounds like... Oh, what did you find? Oh, this one? Yeah, but what is that? That looks like a brick. You need like plenty of extra components. So why buying this instead? Oh yeah, I have another thing. Okay, let's look for the discontinued one. That would be easy. 50 amps and you can just plug it in. Look at that. With heatsink. I like that because we could just put it on the no, it's not here. That's also 12. Wird Elektronik. Yeah, they won't have it anymore. Yeah. Discontinued. Ah, that's unfortunate because look at that. We could just plug it in. That's so cool with heatsink. This is the solution that I would really love, like high power and okay, let's check out the 40 amps. That's also a brick. Then we have this one here. That weirdo, 30 amps. We need 30 of those. How does server storage switch optical? Yeah, that sounds like that's our use case. But this one here, so VRM, what is VRM? Intel VRM. Avanet, that's a supplier. Oh, come on. Voltage regulator. Contact. Oh! Oh, what kind of Chinesium site is that here? Yeah, it seems like this is unobtainium. So this probably is either. Okay, let's try. $8. $8 and we need 100 of those. 200 of those. That's not an option, peeps. That's still too. No, wait, that's 30 watts. Sorry, no. 90. Yeah, that might be it. Okay, let me check Murata. Okay, DC to DC, but you need like a bunch of extra components for that. And that looks huge. Okay, let me check DC to DC converters, but I want. Let me do. The cool thing about this thing here, you can program the voltage. Like there's here, you need just a trim, and then you have also enable pin, which is really cool. I don't know if that you can control it from an MCU because it's like disconnected is on, open is on. So if you do like just disconnect the pin or put it in high impedance if that enables the power supply, because I would like to control the power supplies, turn them on. individually, so I don't overwhelm anything. Okay, let's say, okay, this is the, let me check if I can find this one. That's 50 amps, but 50 amps is probably not like the constant. Controller some MOSFETs and roll your own this point. Yes, I will show you another option in a second. 2D printer style. We need 3.3 volts. Yeah, Terran. Output channel 1. So let's start from 10 amps. Let's see what we got for options here. Apply filters, and then also maybe in stock, I don't know. TDK, $5. Okay, let's do that. Nope. Look at that. Yeah, that's 50 watts, and if you see like 50 watts here, you over voltage CH, yeah. Thirty 66 watts. What is this? We need a comparison, price comparison. Yeah, Murata. Meanwhile, Murata, yeah. I think too, I might be. What is on the graphics card? They need to convert from 12 to 3.3 and even lower ones. So this one here is specifically for stuff like graphics card and whatnot, CPUs, because the output voltage is up to 5.5 and the efficiency is quite high. Look at that. Efficiency is minimum 91%. What is high current on GPUs? That might be like 1 volts or something. What 0.9 volts? What are they running on? Yeah. By the way, this stream is powered by Johnny's new plug-in. It automatically transferred the stream ID. All right, 16 amps. Let's see. Oh, look at that. We have Murata power, but it's not a lot. You can be fine. 60 or 70 of those. Is this one? No. Wait. This is $5 for 55 amps. Channel 2. Channel 1. Oh, that's the voltage. Oh no. Yeah, that's unfortunate. I need to restrict the voltage. go. It's all here. What is this LAN? Okay, that's this again, this Jonka. This Jonka is 66 watts, which would be like plenty of those. We need something more. Okay, more and more. Let's see that again. Oh, 404, bye bye. Huh? Yeah, there is no. I can. Is this the one? I'll be back. 10 amps. 10 amps is $4. Oh, you're right. But what is the cap size for that? Recommended application. They want like a transistor here. Oh, it's the volt. What is this voltage? Oh no, it's pulled to ground. So probably that on off might be like power good internal circuit diagram using guide. Okay, what is efficiency? Yeah, 3.3 volts is 86. That's not the best though. Damn it. Should we make a list? I want to make a list. Okay, let's go calculate the stuff. And you will help me with these cables here. I have the ATX. I need the spec, current specification on these 6-pin connectors that usually have like SATA. Oh, I have even like 3 SATA drives at the end, or disk drive connectors like the old ones, IDE drives. I don't know this. Can someone find the current specification for those connectors and the pins? They're like only 5 pins are populated, and I guess these have also like the other power levels, 3.3 and or 5 volts and 12 volts and ground. I'm not sure. Okay. Let's do the calc here. And there is one thing that I need also help with, if you want to help. We still have, if someone's curious about that, we have to finish this PCB here. And I need to order it quite soon. I mean, I can run the tests. I need to order that PCB quite soon. Here. On this side, there will be the cards plugged in. On the other side, we can plug in the power and some data interfaces. And we have plenty of data that we need to transfer. Each connector has 16 signals that are auxiliary, so we can use it for a parallel bus. They are not mandatory. and one SPI, which is 4 lines. 4 signal lines SPI, and then plenty of power. And I thought this is a good option, like the old IDE, the 80 strand flat cables, because they will be cheap. The 80 strand. Hey Ulis. They might fit in between here. The flat cables, and they have like a weird thing. So if you look at the, let me show it on this camera though. Okay, so that standard is quite weird, because you have like 0.1 inch pin pitch, basic, like you can use basic pin headers, so quite cheap connectors here. But it's basically a IDC connector with a key, and you have only 40 pins here. Some are specified. Hey Api. Some are specified with ground, and what's happening in here, I don't know how it's happening. I never saw that. I got, by the way, a new clamp meter. The old one, but as new. That every second line is ground. It's connected to the ground pins, and the ground pins on the are like, if you look at this PCB, which is basically a USB to IDE adapter, more or less. It was like a drive. You can see like the outer pins are ground, and there are some pins in between, and there are some specs on that, but I need to get it right, because otherwise, if I plug in the cables, they will short like the ground pins with all the lines in between. So yeah, I'm not sure. Need to get that right. And I need like to find specs on that 80 strand flat flags. We don't need to use them. We can use like the 40, but then we have like crosstalk. So I rather use the other ones. All right. So that's that. They will probably fit in between. Let me measure that, by the way. We can switch to that, and here measurement tool. Let's do rough estimate how much space we got. It's like 64 millimeters, and we'll caliper that connector here. It's 50. All right. So we have even like 1 centimeter space. So we will have, we need like a connector for power. Then we need a connector for SPI, 2 connectors for SPI. You can put bets on that. Ventilation, yeah, that's the ventilation hole here. It will be either liquid cooled or air cooled. I don't know. Either I put it in a container or not. And the idea was to have like the inlet or outlet in between here, so you can maybe see that mock-up. So either we put it this upside down, so this board will be on the bottom and the boards will be standing upright, and then we have some convection, or we put like a huge fan on top and it will just blow down and the heat will dissipate to the side. That's probably the cheapest and easiest way, like a huge 50 centimeter diameter turboprop, a turbine, and everything, the electronics on the bottom, or we submerge it completely, and then we have like outlets for this water circulation or water, either mineral oil or some specific coolant that's $500 per gallon. Oh, it's loading. Hey, cyber segways. Oh, by the way, the embezzlement fund. I got a new chair from Yisk. I invested some embezzlement fund for a comfy chair. Oh, no more squeaking noises. 5, 6. Give me the part number for the Noctua, the name. No squeaky noises anymore with the chair. After 5, 6 years, 7 years of streaming. 50 centimeters diameter is the whole thing here. So this PCB is 42 centimeters diameter, and they are exceeding that a little bit. And the container has a 5 millimeter thickness, so we have like 49 centimeters in the diameter of the acrylic container, which costs $400 if I want to submerge it. Hey, CyberSec with we are working on still the ultra cluster. It's loading right now. I'll show the mock-up. Mock-up, it's like the actual PCB, this current state of the PCBs. We have the blades already ordered. The four blades that are ordered right now are combined. Oh no! Why did I zoom in? Oh, saw it here. Yeah, here we go. Okay, the buck converters. I will. How do you rotate? I always forget how to rotate. Here we go. Okay, so we have two. Each module is 512 MCUs. So these two next to each other are 1024 MCUs, and we ordered 4 of the blades as a test, which is 2048, and that exceeds the biggest cluster that I made, which was this one here, by a magnitude. They are 1 millimeter apart. Like, I calculated everything. That's why I put these controllers to the outer side, because here we have 1 millimeter, like 1.4 millimeters roundabout between the QFN chip and the next PCB. There will be more heat, yes, and that's why the inlet. So depending on the coolant or the cooling solution, inlet is here in the center, and it will basically squeeze through the narrow gaps on the boards, and the outlets will be on this side, hopefully, or I don't know. We will find out. I mean, we have plenty of space in the center to basically have like air or coolant blown in between the boards. That's we can print something, we can CNC something. I'm not sure yet. Liquid nitrogen, yeah, and then only one time. Probably it will break the when I think they're not even rated for that. What's minus 40? Minus 20 is the rating of the MCUs. Yeah, so that's that. Oh yeah, that's the, look at that. I even checked the layers of the production file from JC. Yeah, to check if everything is right. Good. This is the power distribution. Oh yeah, that doesn't matter. Oh, there's an island. Gross. So this is the power distribution. These lines are quite thin. There should be a drill. Yeah, there are drills. There should be a drill. Let me show drill file. I have drill file is not shown here. Here, drill file. Boop. Yeah. Thicker vias. Yeah, there will be almost 1 amp on those lines here. It's calculated everything, and then we have the distribution for VCC of the little MCUs, and for the LEDs, which are only 1/3 of the power. And this is for the other controllers. One A sounds? What? 1A? I hope that my ground solution, I have several ground layers. Oops. Ground layers here. This one is completely ground, that I got enough vias there. Where are the vias? Wait a second. Am I missing a file? I show. Huh? Okay, let me check this shortly. Not that I lost all my vias in the process somehow. Might have not loaded everything. Ah, yeah. Production, yeah, because I confirmed already. Can I? Right. How do I open that in the Gerber viewer? Okay, maybe. Yeah, you can see them here, and there's this rendering. You can see the vias there. Okay, did I miss something on my production file? Wait, how do I see the rendering? Yeah, let's hope I didn't mess up. I mean, I can still cancel with when they prepare the PCBA. PCI, yeah. What did I miss? What did I miss? Wait. Are those the right production files? Yeah, these are the production files. Oh, here we go. There is the drill. Here. Huh? Okay, that's ground. And we have all ground layers. Now, it's so weird. Let me check here. No, this is all right. Huh? How didn't I see that? Okay, this is ground. That's why we don't see it. It's just overlapping, but it's connecting here. So it's weird because now it's not shown. This is also ground. This is also ground. All but the last one are ground. So basically, that's why we don't see it. What is SK? Silk screen. Skinix. Yeah. Here. Oh, that's so weird. Okay. I was shocked for a minute, but we have like the drill files is showing it. You don't see the vias because like on all the layers, they're almost all the layers except the back layer, which is not ground. Yeah, all right. Everything's all right. Woo! That was a close call. Somehow, the second time they didn't charge me extra cost for all the drills. Oh fuck! I missed this connection here. That would be another current path, but oh well. I pushed them around so I get at least a wider current path here. We need only like in total 2 amps. No, 200, 300 milliamps here. And that will be good enough. Why won't this NVMe work? Yeah. All right. Ooh, I was sweaty for a second. I didn't show so many drills. Look at that. The first time I submitted, they wanted extra for the drills. I don't know how many vias that is. It's a lot. I overdid it this time. I'm so shell shocked from the previous cluster projects where I had like crosstalk and issues with communication and everything, that I made the line so well shielded with grounds, and I wrapped everything in ground. That's why it's so many drills. Drill kit from Temu. Yeah. Oh well. Let's not look at it. I shouldn't look at it anymore. I just need to receive it and then test it. Anyways, we wanted to talk about... Yeah, we have a power supply. We wanted to solve the power supply issue. So, Murata. Murata Power Solutions. What is this? This is for... That was 10 amps. And that was, it's completely integrated. That's weird. And you place it like that, just reflow it like that. It's like almost like BGA. How do we do that? Do we order it like that? Oh yeah, you wanted to know. Oh yeah, I show you. Let me show you. Let me show you. So the idea was we have this is basically, let's say, which way around nobody knows. These are the clusters. So basically we have like something like that. This is the sketch. Plenty of blades. These are like two connectors here, there, whatever, and we have plenty of those connectors. Then we have power lines, but what I want to do is I want power supplies to be arranged on the outer wall of some sort of 3D printed device, the tube, and we can place heat sinks there. Heat sinks will be vertically oriented, so we have convection heating here, and we don't, probably passive cooling might be enough because we only dissipating more about like 300 watts. Yeah, so we can arrange them completely in circular motion, and then we, oh, you want them right there on this? No, you know why I don't want to do that? Because if one breaks, I have to rework the whole thing. This PCB will only have connectors. It's just connectors, and we have to pick the right ones, connectors, and then we have like power modules that we plug in here. It can be a bigger one, I don't know, we can do like 8 big ones, and then we have on top of that we have like the 3000 watts, 3 kilowatts, and this is supplying the 12 volts to these here. I don't want 12 volts anywhere near this PCB here. So, and this is one thing, is distributing the 12 volts with the PSU is one thing that we will also take care of right now as we speak, my friends, as we speak. Okay, this is my debugging stick. Yeah, pluggable maybe, but then if we don't have space, here. This is basically the side of the container. There is like only limited space. I will show you that probably, I mean, we could try, but it will probably be not enough. Blade base here. Hey ITT. So this board is designed so it could be completely also enclosed in the container, and when I want like some tubes for circulating the coolant from center to the outer thing, this is the only space where I have like 1 centimeter. Maybe I could place them also here, but then I will interrupt, like I waste a lot of space, and I don't have space for the communication lines. I think this space is really necessary to distribute everything, power and the signals. The signals need to go. We will have like a big, let me get a screenshot of that. We can, it's snipping snipping tool. All right, here. Let's get that. Whoop. Let's move it over here. All right, so this is this PCB. Then we want like the power coming in, and then here let's oops, wrong tool. Here is the only space where I can place like get like hoses or whatever, either hoses or if it's air cooled, the outlets to the outside. Nah, I really want to have them either plug-in modules or whatever. So we have the holes here. We can do even like air cooling and outlets to the side. So I really want basically these vents here, even though they are like I can make them bigger, but this oops. Weird. Zoom like that. All right. Yeah, I think the standard is even bigger. There are 14 millimeters for water cooling solutions. My TTS thing, not really. Don't try breaking it. Everyone who messes maliciously with my TTS will be put on hold. Bang PCIe on a I don't think I will be able to put there like a 14. Okay, so that's another thing. Let me check that. Where is it? No. Now I'm doxing myself. Let me find. Oh. Sorry again. What is all that stuff? Huh? Where is my... Oh yeah, I'm trying to find... Where's the stuff that I looked up for... All right. Yeah, that's the cable thing. Let's go to the site of alternate. Okay, alternate. So here. We want PC hardware. Okay, hardware, then PC Wasserkühlungen. Okay, so water cooling solutions. All right, I thought if we use something like mineral oil, which is quite cheap, we could use it's gross. I don't want it. The special cooling things like IPA is too dangerous. You can use different cooling liquids that are more expensive. But I thought, why not try something like that here? let's say 84, and we just place several of those. We could even, I don't want like this PC, that CPU thing here. I don't know if I can get, because this is like an enclosed unit. Who did anything with water cooling yet? So I think that's a closed unit. But if we can get like this unit here, several of those, maybe 4 or 5, or however how many we need to get rid of 3 kilowatt of heat, and basically one is the inlet, one is the outlet, and we can put a manifold on that and basically plug them in those holes here. So we will circulate in on the inner side and circulate out on the outer side, or we can even like put the inlet like a stiff hose on the bottom, so it will circulate like from the bottom to the top. Normal water generate. Yeah, I don't. I think the coolants that you use for, no, you can't use water cooling for submerging PCBs. They're not usually meant for that. You have like specific liquids for that. They are sometimes toxic, so and getting a transparent coolant, because we have like 70,000 lumens that we want still to still enjoy. Distilled water will also not work because it will saturate at some point. Yeah, you can. Granted, the PCB may not work. Yes. So I think the standards for hoses like that. I mean, if we do a manifold anyways, I can take whatever hoses I like. Like one, you can get silicone hoses of eBay. eBay. I have even silicone hoses in different yeah, in different diameters like that. Let's see. Yeah, this is easy. Inner outer diameter. So here there is outer diameter, inner 4, outer 10 is not great. 610. At some point they're floppy, like the 810 is too floppy. So probably you want like 610 hose. It isn't like very intrusive from like the appearance, because we don't want like something that they block easily. Yeah, that's why you buy like the ones that have a thicker wall. They won't block. So if you have like 1 millimeter wall thickness, they will basically fold. The thicker ones won't. I can, you know what? I will bring some of those. I have a bunch of those downstairs. Be right back. Here we go. Look at that, there is even a pump attached to one of those. I don't know what this pump is meant for, but I think that might be, oh, that's probably 12 millimeters. But I think that could work, but you see it, it gets a nick here. We have thinner ones. Yeah, car engine radiator, but you probably get them only used. I don't know if it looks nice. Oh, that's. Oh yeah. Do you have? Is this with built-in pump or not? I mean, we probably need a pump anyways, like an extra pump, because might not work if you have like a manifold. Oh, 600 bucks. Nah, that's like, that's 80 bucks for the ones with the hoses and the CPU part. So we could just get several of those instead and arrange them like 2 kilowatt pool pump is not enough. We have 3 kilowatts of power that we need to. Yeah, PC parts are cheaper. If you look at that, we will get, basically we can put the cooling of the water cooling on here. We have the fans, whatever, we can do it like that. It will blow your manifold in 5 pieces. Yeah, and then everything will spill right on my basically. And here we have the hose, and then maybe we have the manifolds here, which is splitting the hoses into, I don't know, it was 16, 8. If we buy 4 of those, that's 300 bucks. Make a manifold and put 8 outputs. That needs only to suck. A mineral oil, it won't flame. You know how hard it is to combust oil. You need to get it to vapor. There is no way. I want to run them at lower temperatures. Probably below 40 degrees C. Otherwise, you start like to get weird stuff. I mean, the container is acrylic. There is no glass container. So probably like 40 degrees C. And we have like internal temperature sensors in the MCUs, so we can basically monitor that quite good. I like this hose here. It's quite stiff. Look at that. It won't get a nick. I really need to force it. So this one is cool. So that could suck up. Yeah, it's quite stiff. I think it's 2 millimeters. Yeah, it's probably 1.5 or 2 millimeters. Yeah, it says 1.3. It's 1.5 millimeters and outer diameter is 6. And this one is, the bigger one is, yeah, that's only 1 millimeter. Yeah, that's 1 millimeter. 1 millimeter is too floppy, so we want 1.5. Outer diameter is 10. Actually, you know what? I like 10. 10 is great, and inner, let's do 7 or 8. No, 7 or 6. 6 millimeters and 10 outer diameter, that will work. If we want more throughput, we could do that. This is the suction side. So, Not sure. How do we do it? Stick figure what? So that's that part, the cooling solution. I will spend. Hey, Kaspar. Kids drawing, yes, and it's professional content. So I need some specs on, where is it? Okay, silicone Schlauch. Do we have 7x10? Yeah, okay, 7x10 is good. I think 1.5 won't bend, 1.5 won't bend as much. And yeah, that's the hose that we all take and then put on a manifold. That I don't know if we can get that easily. 1:8. If it's upside, if it's coolant water cooled, or how do you call it? I'm a professional engineer. No, water. We can't use water. We can submerge the PCBs into water. So there will be no water coolant. We are using a different coolant. I'm not sure if it will be mineral oil. That's the worst option. The worst and cheapest option will be mineral oil. Yeah, most probably. It will get murky at some point, but it's easy to replace. Not like $500 for a can. And yeah, thickness. Yeah, I can maybe ask a friend at Evonik if he can basically recommend something. He is an specialist. He has 3 masters or something on that topic. Oh, $100. Which one did you buy? The iPhone or Casper? That's a good investment, I think. A9 Pro, is that the one? Oh, A9 Pro is with 2 soldering, or what? Because I have the E9 ED, what is it? 26? Yeah. Why is this running here? I don't want this to be running. Yeah, good luck with the NVMe. All right. So the coolant stuff is not my main problem. In the end, we can do it like that. We put the PCB on the bottom. Wait, let me show it here. Can I scroll by any chance so you can see? There is no option in between. Just zooming. Oh, this is okay. So in the end, if everything goes wrong, we can put it like that. So this will be the config. PCB on the bottom, the main PCB. All that power stuff, whatever, with the cooling to the side here. Power cooling, power. That might be even the easiest way. power, and there is just a frame, and there is this huge fan blower, industrial blower that blows just air in this direction. There is no container whatsoever, like that. Good enough. Let's start with that. Roffelcopter. Yeah, I guess this will work much better. I have I'm using a convection heater here that's 1.5 kilowatts for heating my room, and that doesn't require any fan or anything. So if we put the fan on there, it will be plenty good, I believe. And we can still put something on the top, like a 3D printed air guide that will just guide some air in the center and then around about through the gaps here. The chillers are quite expensive, like $1,000 for a 1 kilowatt chiller. Chillers are pricey, especially for that. Or what do you mean with chiller? Do you mean like the industrial where you cool lasers? Airflow simulation. Yeah, the chiller. Let's see chillers here. Oh, Vivor. 6 liters. Do not want. That's not true. Can't get it that cheap. The chiller. Can you get the chiller that cheap? What's the specs on that? Tell me the specs. And they're not quite. Compressor, refrigerations. Oh, right. What is the cooling capacity? It's a compressor power, but I don't want compressor power. I want to know what the cooling power is. Radiating capacity 50 watt per degree C. Huh? I have no clue. How do you... What is BTU? What is BTU? No, but these are great. I mean, this is something for that where you cool lasers or whatever. That's I would invest in that because I can just plug in a hose and it takes care of everything. British thermal unit, what? Let me check if we can see. It is like a small refrigerator, but it's probably not... I don't know what... Linux setup, what is... You see, inlet, outlet, alarm, outlet, power. That's cool. You can even like sense if it's if something is wrong. But what is the power rating? I can't, oh, 230. I don't care. I would buy that and basically don't care anymore. Oh, did did you use something like that? The chiller? CO2 glass laser tube cooler. But BTU is more or less kilowatt hours. Yeah, but kilowatt hours is a capacity, not like the... Not more air movement, yeah. But this is probably like with a compressor, so more like a heat pump. Yes, 60 to 130 watts. Nah, you see, that is not what we... Compressor Kühler. Case King. So what is here? 1500 watts. Yeah, I need only 2 of those here. Läppische 1000 Euro. One kilowatt hour. 3000. So wait. So what is the what is the KBUs here? What was the specs? Most popular, low returns. What was the specs here again? Oh, that here, kilowatts. 600. 6, yeah, that's not good enough. We need 5 of those then. So 5 of those. If we get, yeah, 5 of those with 1000. It's still cheaper. Vevor. Okay, this is the one. This is what we need. Industrial chiller. Oh shit, I will regret my this life choices. Oh, that's only 1500 watts. Oh no. Shoot. Maybe I need this one. What do you think? Shoot. We need just thermal mass. We need to just pump it through a ton of salt, and we can run it for 1 day and then wait. Shoot it in space. Yeah, but only on the dark side of the moon. 500. Wow, how much is that? Pfft. Chiller for, yeah, no. So chillers are no. Okay, let's see. We can get to. I want to log in. 3 Peltier devices, yes. 2% efficiency. No, that's amazing. Yeah, 2%. All right. Yeah, no more cooling. This will be the fan. Okay. Here. I thought of something like that. Here, this thing. We'll just put it on top. On top of the device. I want. Yeah, helium is a better heat transfer. EU. What is inches? I don't know what inches is. Anyone can explain? What is? We need 50 centimeters. No freedom units. Scarce because of all the AI applications. What are the diameters? Do we almost? Oh, it's a byproduct of from whatever oil industry. All right. What is 1.97 inches? Oh, here we go. Here, this is the one. 16 inch. We need 16 inch. My dudes. This is too big. For yeah. This will be exactly the diameter of the PCBs. Yeah, let's get 16 inches. That's what she said. Let's go 16 inches then. Oh shit, 160. All right. Okay, let's try to get it in Europe though. Can we get it directly from here? This is crazy. All right. Yeah, then I need just the frame. Separate converters at 50%. What? What? I need you know what? Lift let's oh Mon. This one, yeah, ceiling loony. Pappskühler. Okay. Lüfter Industrie 50 Zentimeter oder 500 Millimeter. Okay, we need to find something here. Yeah, I like Vevor. Look at that. They asked me to. Can we directly from here? We can get it directly from here, I believe. Then should we try to get it? I don't like the orange color though. That's too. We might need to recolor it though. But what is where vibrating like crazy? Oh. With all the RGB like this, it will look like this. Yeah, broken soda joy. Oh, yes. Yeah, we need to decouple it. Speed. We can increase the speed. Ooh, look at that. Look at that. That's yeah, I know it's the cheapest brand, but that's all right. This is not the solution that I wanted initially. This is the fire starter. Yeah, but what is it doesn't say the diameter. Doesn't say the diameter here. We can get it in blue from Shepach, most probably the same thing. Oh, look at that one. That is completely black. But I guess it's not as powerful. What is CFM? 4000 CFM. Cubic 4 meters. Foot meters. Oh yeah. Gross. 7.5 meters per second. 90 watts. 1500. I want a slow one. Wasserdicht oder nicht? Ja, ohne. Ja, ohne. Auf Lager. The black one, I like the one that's like encased. Oh, look at this. That looks fancy. Super fast. How much current per board? 40 watts. More or less. Yeah, it's basically 100% efficient. Ooh! Oh, that looks cool. What is this? Rohrventilator. Oh, this is not 50 centimeters. No, that's DN 6, yeah, 16 centimeters. Oh, that's big. But that's also quite substantial. How you calculate? I missed that. Oh, look at that. HB machines. That one is black. This is this exactly same thing. It's just a different color and twice the price. Look at that. This is the exact same thing like the Vivor. Yeah, yeah. Let's compare it. Oh yeah, no, it's not the same. Oh, that is like 2 axis control here. I don't need 2 axis. I want 1 axis, but black. What is the biggest PC fan that we can get? What is this? 25? We need like... And this is... Design choices. How do you design something with less power? Oh wait, CNC. Oh yeah. Anyone saw anything about the Panda Placer? That's like an open PNP thing. It's quite cool. Very basic pick and place. Probably the the cartridges are the most expensive thing. Pondered? What does that mean? Bad? They claim they can do all four of two components. I say, like, I mean, okay. So cooling is not the highest priority right now. This one is cool though. What's the industrial fan cooling bearing? 40 dBA, that's cool. But what is the... Yeah, that will probably not suffice for airflow. There is a transparent one, 22 centimeters. That's cool. Oh wow, there are some cool options. Terran, it's the LED is a gimmick. We want the computing power. See what Sonic has. Easy vent. Schallgedämmter Rohrventilator. You got that? For summer or what? It's a computing cluster with 1 MCU per pixel. So yeah, that's that. The LEDs, they take 3 milliamps. The MCUs take 10 milliamps for computation at max. I mean, we measured it is lower than that. This is how one part of the cluster looks like. These are 32 MCUs and one controller next to it. And we will have, of those, we have 16 per board. And we have 128 boards. So that's why we end up having so much. Oh, that looks cool. But there, the diameter is too small. Okay. Ah, shit. Why? What? Oh, I like that with the orange. The frame is black, but the orange thing inside. Axial ventilator. Yeah, I'll probably end up buying the Vivo because it's just a... Corsair? What? Again? What is this? 500 million? What? I mean, we have already the power supply from Corsair. Where do you get that? Sponsorship, yeah. A suck RAM out of... No, it's probably running at a low RPM. Yeah, no, we can... Oh no, that's the same name like a... it's probably not unobtainable. What did you find on Amazon? Mon. Oh, I can't. The link doesn't work. Can you shorten the link, Mon? That is broken for me. Okay, Vevor was what we can do. Baulüfter. Baulüfter. Yeah, this is more what I need. What? 2,000 euros? No, thank you. Vevor again. 80 bucks Vevor. Profi. Oh, this is the 2-axis rotational part. Baulüfter. It's like a tube. I like the tube style thing. But if it's only like flat like that, that's alright. Baulüfter, Kleinanzeigen. Maybe we can get one for cheap. Nah. This is what we need. Okay. Shepherd. Or we get a red one from, what is it? The other cheap brand. Bauventilator. No, Shepherd doesn't have one. Oh, the other brand. Let's look for that. Yeah, that's always this one comes up. Bitluni 4. Okay, here we go. 12-inch. Okay. Slightly. Oh, that's like for cooling a motor. A radiator. If we can like get the radiator directly with it. It's not like really expensive. But it's 80 watts. I don't know if I have spare 80 watts. Maybe. Yeah, I could run it off the power supply. Okay, that's certainly an option. Universal radiator fan. Okay. I need to open that though in the other browser. Alright. Okay, let's go back to the power. So we have options here for like cheap alternative Vevor. 80 bucks. Cheap. What is the cheapest that we can... Oh, you know what? Geizhals. Because that's so big, we probably want to get a ventilator. Get it directly from Germany or Europe. Bodenventilator, Decken, Handventilator, Nackenventilator, Standventilator, Tischventilator. We have more filters. We have plenty of filters here. A Flügeldurchmesser up. Okay, so up. Okay, here. This is basically the fan diameter. Bis 50. Yeah. I mean, this is like the cheapest option would be just to get one of those. I mean, I have even one that I could use. Because... where is mine? It's probably also... If you look at that thing... like here, you can open this up, this cage in the front, to clean it up. So you can basically open this cage up and then just put it on top of our construction or whatever. And get rid of the rest and plug it into power. And what is the price for that? $20? Yeah, $30. Here we go. It's probably not as... It's very... They are made to be quiet as well. Might be capable of doing the 3 kilowatts. Like dissipating that. So I'm not worried about that. Can we see what else we got? Yeah, we want that, but in round. Here is a one. Yeah, this is... Look at that. Oh, that's 41 centimeters. 43. Horizontal oscillierend. How is that oscillating horizontally? That can't be. Oh wait, horizontal. You can rotate that. In Darmstadt? When have you been to Darmstadt? Did I miss something? Did you live there? Oh, really? We could have met there in Darmstadt. I lived there from 2000 to 2019. Yeah. Yeah, I was at the TU Darmstadt for 15 years and working everywhere there, basically. IGD. I worked Medcom. I worked like that was my huh? How did we miss that connection? What did you do in Darmstadt? Yes, basically. Oh yeah, that e-reader thing. All right. That was in Darmstadt? Cool. All right. All right. Yeah. We can take this one. Doesn't look very optimized, sound optimized. Very noisy. We have options. Now back to our power solution. Middle loud, yeah. So, I need to distribute this power here. This power across plenty of little things. The issue is I have 4 cables. By the way, these are the 600 watt cables for graphics card. Yeah, but that's only 2.4 kilowatts max with 10%. And then we have, wait a second. Yeah, all right. So, and then we have the 8-pin connectors. I just plugged in every. Okay, let's turn on the camera, and I will rip out a connector here. Yeah, it's so dark. Why is it so dark? Can I set the ISO? No. Huh? Is it already too dark for that? What is the max ISO? ISO limit? Yeah, alright. Higher ISO limit. Your PC is not harmless with your graphics card. This power connector it doesn't look like it sits well in there. I don't know. So the thing about these connectors, what's the name again? I have a window open with all the search on that. Where is it? Yeah. That's that. So 12 here. Okay, not doxing myself, but here we go. Here. Weirdly enough, I would like that RTX 4090 had one of those that splits into 4, even though like it makes sense, because if you look at the specs of the regular, where is the comparison? Yeah, the 8-pin power is specified for 150 watts. And since they are like a higher gauge, they are specified for 600 and they have less tolerance. We have like your fault tolerance, like plenty of headroom. With the 600 watt cables we don't have. So it's like okay to split it into 4, but you will never find these adapters. Please find me one of the adapter that has 4 outputs here, because you don't have enough wires. You have like 6 pins that run that, and you have 3 pins on these ones. That's why you get only adapters from here. $15 from 600 to that, because I would rather want to, instead of using this connector on the other end, I would rather want to basically distribute the power more evenly on all those mini converters to distribute the current a little more. We have 900 amps that we want to output at the end. So anyone can find one that basically goes from this to 4 of those. Where do you get this adapter that's shown here? That would be better, but then they have like to crimp 2 wires to 1 pin. That's why probably they are quite rare. Because if... Oh, you found one? Galaxus? Sorry. That's alright. That's 3. That's not 4, that's 3. But it's better. I don't know Intertech, but... cheap supplier. Yeah, I don't want to things get melted, so that... Yeah, Sonic that URL. What do they save there? They have like your whole desktop stored in there. There is no limit to the Chrome TTS. YouTube shortens the links. Twitch doesn't. Duxen? What? Duxen? Still going on? No. You would definitely not use any of those types of connector. Why? ITT. So, what is your option? Like, what would you do to go from this here? So I want like an off-the-shelf adapter. I mean, we can get like a PCB adapter that has like 4 outputs, but so what would be ITT? What is your solution? Your personal solution on that? I'm interested. If you have a good one, the best would be off the shelf. Like, PC components are cheap. If we try to like crimp cables ourselves, there will be fireworks. Especially if we have like 900 amps in the end. Oh, XT60. You got one? Oh, nice. 1699. All right. Is it 600 watt rated? That will be cool. But XT60, you need like to solder the wire at the end to something. Like, would you solder the... Is it made for 600 watts? Is it spec'd for that? This 600 watt. Okay. 16 AVG. All right. That's what I wanted. Nothing more or less. Boop, in den Einkaufswagen. Oh, you have all the options. There are also... Wait, there's also another one for 16... Yeah, but this is not... That doesn't look like a 600 watt. Yeah, that is sus. Is there an LED inside? Yeah, I don't want extra LEDs or something. That doesn't... 600. What kind of brand is that? I don't see a brand. Bolazul store. No. I trust this one. This one looks good. I don't want LEDs. I don't want... Yeah. Yeah, so... if I wouldn't do XT60 connectors or XT30 or whatever. I mean, I have plenty of those here. We can do what is the amps? XT90. I think I have XT90 as well. I show you which ones I like. So I can't find the XT90. I probably use them all for my car projects or scooter projects or whatever. But separate which ones? XT90. So these are, we have even like smaller ones. This would be probably good enough, the XT30. That's, I think, XT30, yeah. XT30 would be probably good enough for a wire of this gauge. What is this? Yeah, that's probably fitting the size, but I don't want to solder that to a PCB. So what would you do? Like, I would need to get the wire, like change it to this connector and then PCB mount. Yeah, but no, I don't. No, this board depends which. If I the ones that I liked were this. I have like even bigger ones. That these are like 4 millimeters and they have plenty of connection here. Like these are quite cool, but also I have like XT. I have more. Yeah. Okay. Okay, so we have 3.5 millimeter. Then we have some serious stuff. Oh yeah, these are cool. These are for quite high current. But look at these chonkers. Look at these chonkers here. Look at that. Ugh. Focus. That is like some really good connection. Yeah, that's quite thick. This is 6 millimeters. This is better than XT90, I would believe. Maybe comparable to those here. Do I have female ones? I don't see any female ones here. Yeah. Because they're like longer. But I don't want to, I mean, I could right away, instead of using an XT connector, I could, if I take the cables, the power supply cables here, and if I cut them anyways, I could directly solder the wires to the PCB. What is the difference? Then I have like one. There is no like stiff connector that could like break the PCB, and we would have a direct connection. So I would rather take cable like that. Look at that. We have like both ends. We can take one cable, split it in half, solder it directly to the PCB. That would be easier than like trying to get XT60 or whatever. Same type D sub. All right. Then, but okay. Now the other question is. Oh, I like also these T-plugs here. You can't like plug in like the wrong way, and they have also a quite good area. PCIe connector. What? What? I missed that. Oh yeah. So from this from this to the DC to DC converters, we will split it by, we have 2.4, we have those here. All right, ITT, you have too much time. I'm really on a crunch here. I can't like modify the power supply. Also, that power supply is pricey. If I break it, I want to return it and get a new one. So I will not mess around with that one. Okay, we have quite a few on this side. So this is 1, 2, 3. Probably I won't be taking like 2 of those. So 1, 2, 3, 4, 4. Oh, these are the other ones. 4, 5, 6. So we have 6 of the 4 and 4 of those. So we can 4, 4 and 6, but it's not 16. I would like to have 16. How do we get 16 out of that? Wait, this is 4 times 4. Oh, we have 16 like that, and then extra 6. 22. That's 22 connectors that we can, like, of those 150 watts. 150 watts times 22. But I can't do. So I would like to distribute the power evenly. It seems I can't. So if I take 16. Okay, let's see, 3 kilowatts, 3000 divided by 16, because clamp meter. Yeah, okay, let's try. Yeah, there are grounds in between, and we need to split them like grounds. I think they're on top of that. We need only the half of that. At least we can get to the ground, to split it, the ground and the 12 volts. Look at that, that's cool. Could measure that. That's cool. And this is the new one. It's like the old one, but it's new and not broken. We can use that. Okay, let's assume we can do 16 4. We have 4. That's 4 times 4 is 16, and then we have 6. Yeah, it's not. It's weird. 187 watts per. If we split it by 16, we are at 187 divided by 3.3. 56 amps. Oh, that's so close. But there is no headroom, so we would need a 60 amp output buck converter, or how do we distribute it? We have 128 PCBs that we need to supply with plenty of power. Yeah, it looks like I need a sheet. 24. Let me check my PCB. because I distributed it in a specific way. They are like, it's not the right one. Yeah, it is the right one. Okay. So we combine 3 each. So we have 4 inputs that are combined. VLED is also, is it combined? I don't think so. Let me check that on the PCB. I have no extra lines for that in the design, unfortunately. That didn't work like that. All right, so oh, we actually have 4 different lines for that. So we could split it like however we like here. The thing is, I don't know how I want to power it up. Imagine if I like start one after the other, so we don't like hit it with 3 kilowatts right away. I could start it like this section. If you let me remove. It's a little bit weird because the power for here, the LEDs and the core power is not aligning. It's like 3 MCUs or 4 MCUs, and then we have like the LEDs, which are, yeah, it's always 4, but one might not light up or whatever. So I'm not sure if it's smart to split that. I might even change the design later to have just one big 3.3 volts coming in here for VCC MCU 0. Typically yes, because they are floating, the pins, unless there is like a reverse voltage issue, whatever, I don't know. Yeah, I saw when we have I think MCU power, I had once an effect where the red LED was slightly lit. Some weird current thing was going on there. Probably it was flowing not to VCC LED. It was flowing like from one pin to the other pin of the MCU or something. It was a little bit weird behavior, but that's not like a common thing. We can't. Oh yes, maybe we should split at least the LED power from the MCU power. So we have at least two powers per board that we want to have split. Also, this one might be a different power level. So if we use regulated power, I don't know, maybe we should use all the pins here like that and decide later. So the issue is we have current wise, I need my sheet. My sheet knows better. Is my sheet somewhere here? Oh, let me check if we got. Now JHC is sleeping. There's no review. Okay, here we go. Power calculations. Alright, so we are at half blade. This is the one that we are doing right now. We have a total current of 7 amps per blade. That's not much. Yeah, that's weird. How did I get 900 amps? $128 times that. Yeah, it's okay. What? Shit. All right. Yeah, this it is what it is, peeps. Wow. Okay. Oh, that's a lot. That's a lot cables if I want to. Oh shit! I didn't think about that properly. I mean, if I want like these old IDE cables, I can only put the data lines of two of the blades on one cable. 40 pins, 16 plus 4, and there's no, only the ground. I could, yeah, I could put SPI and the other lines on one of those cables. No, I can't because there are more grounds than actual signal lines. So I can put only the auxiliary on that, and I need like extra cables for SPI, which is 128 cables. I need to source them. I need to start sourcing cables right now. Uh-oh. And how do we combine that? I mean, we need to still develop the interface to the FPGAs to combine that in some way and form, or microcontroller, like a simple interface. Oh wow, that will be challenging. Mon, please, give me all your knowledge about the 80-pin cables. I need it all. So my maximum frequency data rate is 32 or 40 mega bits or megahertz clock rate. Round about this frequency. That's the maximum I can do right now. Maybe I could do 60 at most. If we can someone like burst it with, but no, that's not possible. DMA, yeah, maybe with DMA I could do 60, but that's the maximum. I believe even DMA can do 60, more like 32 or something. What? What are you talking about? Oh no! We can wrap it with aluminium foil ourselves. PCI connectors alleviate any cables. Yeah, if we put it on there, we can put like different connectors on this side, but I don't know if we can. If you look at the PCB like that, I don't want to put any logic on that board, because whenever I change something, it will be. We could improve on that, but we need to put power here everywhere. I mean, we could squeeze in like a board in between here somewhere. No, oh no, you got it wrong. Sorry. Wait, I'll show you. Okay, so we have the PCI Express is power here. These pins are power, and then we have data pins here. which are like 16 parallel pins and an SPI. And what we need to do, we need at least the SPI. The SPI is like the lowest, the serial interface, the lowest that we can just to start up. Yeah, we need like a balance between cost and effectivity. So what we don't want, like, it would be the best to have like all the data processed on this PCB, but designing the PCB like that right now is basically we never get finished in time. So I would rather put connectors on here, like this IDE whatever, to put there, let's say, the parallel data, and then one connector per PCI Express for SPI, and then we can basically place whatever, because this is like very congested. We have lots of cables, lots of power going on here, and then I can just consolidate the cables, put them on one square board somewhere here, which is basically the brain, and then we can maybe even make a square interface to the outer world, which has all the ports or whatever. So yeah, most probably I would rather take some connectors on here, so this whole board is only connectors, and then I can not mess up much with connectors. I guess we can still improve it later to get like better interconnectivity or whatever, or place MCUs that process that stuff, or the FPGAs on here. We probably need like four FPGAs or even more if we want like the parallel data to be processed. Or we do one parallel bus that goes around, and yeah, they're like addressed individually with the SPI, and then using that just to get it faster. But the SPI could be done in parallel if we use like the FPGA, because we have plenty of pins there. I don't think we have enough. UFO, yeah. How many data lines? Okay, the parallel bus has 16 times oh, 128. Oh shit, that's a lot. It's 64 of those cable. Oh no, it sounds wrong. Oh no, no. There is no way around of putting some wire wrap. Uh, no, that sounds gross. Shit. How do we do it? I can imagine like 80 of those cables. This tube, this will be like a huge. Maybe I will make like a whole container underneath it. Oh, damn it. What did I do? This project is getting out of hand. I need something to digest the data right now, here, right in place. But I'm not knowledge enough to use the primer 25K yet. Because we could squeeze that in, at least the connectors. Look at that, the mezzanine connectors. They're little. We can place there like. I'm not sure if what pins you can use to process all that stuff. That would be cool, just to put the footprint on there. Yeah, it's plenty. Cypede. You know what? Maybe we just Slim SCS 16i 124 pins. That sounds. What is the pin pitch on the PCB? If you have the connector. Oh, is this flat flex? No. What is this? Oh, that's specific. Is it like a flat flex cable? No. We can use flat flex as well. We could do, if we use a flat flex which has a ground plane, then we that is impedance matched. That would be perfect. PCIe 16 razors. Yeah, you're right. Like I have one here. Where is it? Huh? Huh? I lost it. Oh, my foot. Huh? Where's my PCI Express? It's quite slim also, but it's like for differential pairs. Not sure if that is. Uh, 16. Do you have like a good link to that information, or like an example where I can like Amazon link anything that would help to get me like an anchor for that, so I can research later. Can find this PCI. Wait, that is in one. That should be in one box though. Here. This is my PC. No, it's not my PCI Express. What is this? Come on. Load it already. Here we go. Oh, it's a PDF. All right. Oh, 85 ohms. Oh, okay. That doesn't match what but in the end I don't care. Straight to straight 4 times size as 8 times. But that's okay. That could be used. Oh, that's probably differential pairs, is it? Side. That looks like SATA connector cables. I could use SATA for the SPI stuff. How many lines is that? Doesn't look like... It looks like it's a lot. What? Huh. Okay, okay. Theta and PCIe. Okay, so this is an option though. Now I'm interested in if I can. Let me just grab a hard drive. I'm wondering if I can use a SATA cables for. That's quite cheap. I can get them for below $1 because I need like 128 of that and connectors and everything. That will be quite pricey. Okay, so SATA has 7 pins. Oh, that's perfect. There's ground, data. Oh, that's 2 differential pair. What? How is that meant? SATA is looks alright. Let me check that. Yeah, that's the power. That's the power pin. Twin axial. SATA. They're like really compact. Now that I need like a simple solution for yeah, look at that. They can be really slim. Never. Forget 128 of those. SATA. It's so expensive. Maybe it's better to put the the processing on the PCB itself. I will spend $1,000 just for the interconnections. I need to think it through really thoroughly. Copper, yeah. Copper is the easiest. Yeah, the mezzanine connectors for that we have for the Tang Nano, they are quite dense. Look at that. Oh, you know what? I will turn on the microscope. We can take a look. Peeps, let's take a look. Haha. Yeah. Did I plug it in? Oh no, it's not plugged in. Yeah. I'm divided if I want to actually put the mezzanine footprint for the mezzanine connector already on the PCB to process the data there. If we can do it. like you will see here. Oh shit, what did I break? I stepped on something. That's trashy. Aluminium cables. Auflage. Tritt sich fest, ja. Oh, you know what? AliExpress and Alibaba, and then I want 1,000,000 SATA cables. Please give me. SATA to USB. No. SATA. 100 pieces. I don't want 6 gigabits per second. I want 100 megabits per second. That's good enough for me. Okay, 100 pieces not there. Let's check. 10 pieces. Oh, here we go. Look at that. How short is that though? 100 pack. Here we go. Problem solved. Slimsas? Molmon, you have the right to post a link. Feel free. Slimsas? What is it? Slimsas? Yeah, that's... Hey, Johnny. We're trying to interconnect 128 SATA cables. Mini Slimsas. Yeah, here we go. Boop, boop, boop. Good luck with that. Oh no. Slimsas. Okay. Slimsas cable. 279. Is this what you mean? Like this price range? Is this more or less? How many pins do we have there? Oh, nice. Tacos. This is where you can eat as many as you want. Or you eat as many as you want, and then... Is it to both sides? How many positions does 38 pin 38 pin but then we need like one per. It's not enough for. It's enough for one. Six times SATA on the other side. Wait. I would. What does 4i mean? Sorry, I am stupid. 4i. What is there like a bigger 8i, 10i? Here, this one. Ah, here we go. This is a bigger one. 8. But then we need like 64 of those. That's the issue. It's not like cheap. Anything that's above, for a cable above $1 is already, I need to consider, because this is like, if I this will be, how many pins are those now? That's 4 times positions are those? Okay, A and B. No, SATA is basically for the serial interface. I need something for the parallel interface. So I have like, I will show you the design here. Ah, come on. Too many here. All right. So what I have right now is here, chip select, MISO MOSI SCK. This is the most important. This is the serial which we can use for data. This is, and we can handle that easily because we got so many boards and we need somehow to connect them. This is something that we could do with an FPGA, and we don't need many FPGAs to handle those wires. But then we also have, look at that, like a whole bus of, oh no, that's not, yeah, this is the bus that's coming in, PA0 to PA15. I just put it on the connector to have the option to have also a parallel bus which just can transfer way more data, because we can receive, I don't want a bottleneck somewhere on this higher level. This is already level 3, level 0, level 1, level 2. This is level 2. So we got already, like, level 0 is already 32 megahertz serial. The next one is also 32 megahertz, but like we have 32 that comes into level 1, parallel with over USB. No, what? Oh, when did I do that? I don't know. I can't remember. Anyways, this is like, I want just the option. This is the parallel bus here is optional. I can replace one board, like on if you look at this here, this is the expensive part, these boards. If I manufacture them once, I want the option for them to have like a fast interface. We don't need to use it, the parallel interface, the 16 lanes. So since this, how do you, I always forget how to rotate. Since this board will be quite stupid, we only need to use in the beginning to have the bottleneck of the SPI here. We only need to put on like the SATA connectors for each of the boards here to use it for. We can put now. We can one SATA connector per board, which is 128, and then have the option, let's say with cables like these or the one that you suggested, for the parallel interface, if we have like the means of computing it, or we can replace this single board with three. Yeah, I don't know if it's supported. Probably it is. I always wanted one, and I used 3D mouse at work at Exocad, because I wrote 3D software there, so I'm quite used to using a 3D mouse, but never bought one. Should get one. Alright, so we can replace this board easily at low cost, because I will assemble this myself. We will sort out those connectors. They should arrive like next week or something from LCSC. So I have it's only connectors and a PCB right now. Tripled? What? Why? How? Weren't they like $100? No, was it 40 for the, no, the one, the basic one? I like the basic one that looks like a puck and has not many extra features. 50, yeah. Yeah, that's what I think. Hey, Deshipu, you are not. You might be able to bring some suggestions how to get like a lot of data transferred over cable from that board for really cheap. So we have 128 SATA is an option if we get the SATA cables from AliExpress. Where is it? Oh yes, they could be addressed individually, one. I don't know how. I mean, the Primer 20 SATA N66. What? What is that? Oh, Satan! You bastard! You got me there. You got me with the dash, dude. I was confused. 666. That sounds weird. I take anything right now. I don't. Oh, look at that board. I like the cooling body there. I want something like that. Dyselectric Satanist. I lost my window with the. Oh yeah, I wanted to show microscope the mezzanine connector. We could put it on there. The issue is if I put have like a star configuration in my lanes that reduces the signal integrity. I shouldn't do that. So I'm not sure if I want to put like the mezzanine connector on there, or at least like the wiring for that. I will. Where is it? Here we go. So I found the right connectors for that. The Tank Primer 25 has a lot of I/O pins, so thank you for the suggestion. Whoever did that, probably Casper, or who was that? I don't want to. Okay, so I found the right connector on LCSC. Look at that. Yeah, plenty of pins, little connector, plenty of I/Os. It's meant to be fast. And yeah, look at the size. Look at the size of this connector. 6 millimeters. Oh wait, no, 14. Sorry. Yeah. Oh yeah, 14. Sorry, can't read. Dyslexic engineer. 15 millimeters. So the issue is, if I wire those, I will have like a star configuration between these here and whatnot. But I could actually, you know what, for the parallel processing, I'm wondering if I could ignore the parallel lines, just route them to connectors like to the footprints of these modules, and then in future just get that and make it faster. I don't know if we even need it to be that fast. We don't need it for YouTube, for a good YouTube video though. You can always fake it. Fake it till you make it. Yeah. But these connectors, they're not really expensive. And we can use, what was the pin count? Like they are really tiny. I don't want to break it. Oh, look at the soldering iron. Oh, this is my new soldering iron. We can oh yeah, this is the small one. Okay, let me switch the tip. Eh? Don't I have the holder here? Yeah. Here. Okay, so we will be able to solder that. We might need to reflow it though. Oh, if we have the connectors already on there, it will be hard to reflow. So I need the footprints to be exactly matching, not like here. Here you can see we have like this, oh, is it sharp? Yeah. The footprint is bigger than the pins here. I need the pins, the footprint to be exactly as big as that, so that aligns. Otherwise it will be pain in the ass to plug that in. That's a cool thing. Then we need to get more of those then. Yeah, it's like completely different adventure to make these ones work with the parallel lines though. Let me check that. Really cool connect. Oh wait, let me unplug it. Oh, our new tweezers. Yeah, but I don't want to bend it. It's titanium, it shouldn't bend. Look at the tweezers. Yeah, I can't get this connector off there. I don't want to break the tweezers. Let me use old tweezers. Yeah, these are the old ones. They are way more thicker here. The tip. How do I get this off? Can't get this off anymore. It's here to stay. I have a knife. Here. Let's pry it off. Here. Here we go. It's a little bit compliant. It looks like it's rubbery almost, huh? Oh. Yeah. Okay, let's not break it. I think it's 60 cents per connector or something. So it's like $2 per. It's almost like, look at that little thing. Cool, huh? Okay, let's take a look at the primer, but we still didn't solve our issue with the power. I'm all over the place. ADHD at max today. Prost. It's only booster. I had like while I was researching how to interconnect it, and I thought, oh yeah, I want something impedance matched. And you know what also came up? Like Polish beer? What? Yeah, and Prost. Na zdrowie. So look at that would be an option. A board interconnect that's impedance matched for 50 ohms. Okay, I wouldn't use these big ones, but you can use the antenna ones. They're really small plugs. That would work, but I think SATA might be cheaper. Okay, so let's check. What was 14 millimeters was the size. Let's consider. Oh, you know what? We can draw that on the PCB here. Yeah. large number. I need then 4 per board. That's like 400 antenna connectors. What is the bulk price of that? It's the little ones. Here. I meant SMA RF1. Is it RF? Oh, what is that? This end, the small end here. What's that called? I want oh, what is this? Female SMA. STA, UCI. All that names are different from what is here. Okay. What? UFL. Oh, IPX1 is what I want. More or less, something like that. Yeah. But I want IP. Yeah. Oh, this is just one single end. MHF4. Yeah, could be. IPEX. Yeah. Oh. What is the... Wait, more. Pin count 50, 40, 50. Coax. Looks interesting. If we can find a supplier of those, it would be cool. All right. It looks like there is none, like from that to that. Like, oh, there is one. 25 cents. This is what I wanted. Okay, only 5 centimeters. If you get 39. Very small PCB sockets. Yeah, that's all right. We don't want to waste space. This is like the perfect interconnection. This is like there is no cable whatsoever. Because it's completely like a singularity electrically. Almost. Antenna cables are black magic. Oh, UFL is brittle. Yeah, especially those probably are quite brittle. How do you get like a... I want 1,000,000 of those if I buy them in bulk. Almost like a hair. That sounds like it's the right size. What is this? This is also nice. But I want like 100 pieces. Here, 1 piece. 2 pieces. Okay, so what do we get? I want... Oh, really? No, yeah, now I have to look. 100 pieces, 45 bucks. Here we go, peeps. Yeah, we can take the bigger ones. I don't care. Okay, 53 bucks for... Oh yeah, 10 centimeters is not long enough. Ah, you have Wi-Fi on your PC? Yeah, I'm wondering, okay, that looks like that could be a reasonable price if you can get the connectors as well. I mean, you need to always have the Bluetooth, yeah, right. I have just a USB, just a little USB dongle that's working like that for 5 years. It does the job, it does everything. Like my earpiece is running through that. It's really good. Alright, so that was an option. Where was the SATA cables? SATA cables were also quite cheap. We need LCSC, SATA connectors. Oh, it's already. Custom flat flags is an option. Give me, I mean, it doesn't need to be custom flat flags. If you can make, if you can find the flat flags that has a ground plane, then we can spare a complete, because now I have like yeah, probably the shipping cost is more expensive than just buying. The combined shipping cost is more expensive than buying the bulk of AliExpress. Okay, let me check that. Not that it's like a benchmark or anything. Here we go. 13 cents. This is what we wanted, didn't we? Are they both like female, the cables on both sides? Or what do I do? Is there like... Look at that, that's 7 cents in bulk. That costs nothing. I like that price. Oh yeah, I'm sponsored with JLC and they can also gift me flat flags if I want to. But you still need the connector on the other side. Yeah, so that's why we always take something that's that was common when building PCs, because that's like the mass production, but also deprecated. Like if we have cables like that, there is some seller that still has like a warehouse full of those cables and connectors, and they want to get rid of those. Or we get something like more common, like this here, SATA, SATA power. That's also quite a few pins. It's like a combined SATA connector. But yeah, you can't probably get a cable that's just meant for power, the long one. Okay, I need to check what kind of cables. Where is our window with the SATA cables? Pigtail, no. Here, this one. All right, so it's female ones on both sides. Okay. Okay, female ones, so we need connectors. I like it's yellow. I don't mind. 40 centimeters is the right length that we need. 30 bucks. I will just buy them. But I need more than 100 pieces. I probably get, wait, 10 pack, 50 pack. I can just get maybe 150 in total. Here 9. Yeah, that's 40 bucks. And that's choice. Yeah, add it to cart. Here we go. Add to cart. Am I logged in? No. That doesn't. Ark. Oh. Okay, so we have. This is these are grounds and these are the data lines. Is it like that? But this should be, oh, these are differential pair. That's meant for differential pairs. Oh no! If I do chip select on one of those, chip select, Misomosi, no, clock, foo. That's not good. SATA is probably not suitable. Because we have crosstalk. I mean the distance between so engineers, please help me out. The distance to ground is shorter than the distance because we have like two insulators here. So the distance between the data lines is longer than the distance between ground and that. Yeah, I can bitbangs differential signaling, but then I could use DMA, but it's like a lot of processing power. I could do it. Not sure. Maybe we should test that. I don't know if we have the time to test crosstalk here. We could test this. I can take a SATA cable, cut it, then we use a signal generator to give it a square wave and then measure the crosstalk with connected ground and disconnected ground. Oh, okay. Sonic, that's a good good thing. I will probably take that hint, open a window and try to consolidate that. Oh, I like the vertical connectors here. Oh, look at the red connectors here. Love it. Colorful. Yellow looks good with pink LEDs. I like the connectors here. What is the pin configuration then for the long? I guess the long ones are the grounds, shield, like ground, shield or something. Well, what's the pins? Let me check that. Yeah. Ground differential. Yeah, that's what I thought. Two differential pairs. Sorry. Ah, damn it. Ah! Here. Hmm. Ah, look at that. It's so crazy that this one is faster than this one here. I probably will never use the parallel thing. But the parallel we could use as a differential 8-line differential thing. Because I put it on port A completely, we could basically take the first byte, invert it, put it on the second. They're not close to each other, but if we would wire it like that, we could use it as differential, 8-bit differential signaling. Now we can like send it over 40 meters or something. Yeah, we take like Ethernet cables and use that. Oh, I'm getting tired. It's already. Okay. We need to test the SATA thing before I buy the cable. VDS CSC. Yeah. If it was like 4 lanes, that would be cool. With 4 lanes, we could put a ground on the other pair. Like D plus would be signal, and then we can't have. Lost it. Micro SATA. Wow. That's probably too old now. Okay. Still not logging in. 986000. This time 64. That's quite pricey. Maybe Pauline has some of those. Something smelled like burning electronics here. Oh, by the way, I found it. Here it is, the cable. This is weird. I hope my PC doesn't burn. Maybe it's a cap or something. I didn't hear a pop. 40 pin, yeah, but 40 pin doesn't have the grounds in between. I'm not sure. Maybe I will just put the mezzanine connector footprint on there. You know? I can smell it. It smells like something's burning here. Soldering irons, I didn't turn them on today. It's weird. Maybe irritation. I didn't plug anything in. Weird. Yeah. It's not like it's very subtle. Probably nobody would smell that. That could be also like a scent that you have like on your hand, but my hands are not. Or it's coming from the hoses here? No. No, yeah, they are rather moldy then. Or like, it smells weird, but it's not the same smell. Alright, alright, alright. I need to be careful here, peeps. That smells like fresh rubber. We will find out. I have a smoke detector in here. And the battery is in there as well. Okay, we wanted to check EDE. No, nothing. Here's nothing out of ordinary, really. I didn't turn anything on except for the lights for the microscope, but that's further away. It smells like coming more like from my PC. Not really. Weird. Or my servers here. Not that I might. There's no batteries or any. Oh yeah, I have batteries here, but this is not connected. My old microphone is here. Oh yeah, I have batteries here, 9-volt batteries. But they are like still sealed, so. No, that's a different smell. It's a more of a good smell though. Wait, alright. Oh, wait a second. There is another option that we can have, like ESDN cable or USB, micro USB cables. USB is not great. We have like one differential pair only, unless it's a USB 3 cable. Okay, so what do we have? USB-C? USB-C can be still USB 2, so we need like USB 3 cables, if any. Okay, wait. USB Festnetz Zubehör. Was there like... Huh? Refurbished. Was this? Fujitsu PC. Bauelemente. Now, where do I find? Oh, look at that. All right, I can already get SATA cables here locally. Yeah. Oh, interesting. Yeah, that's the long one. Hmm. You know what? We will use VGA cables, D-sub connectors with uh 30 positions. But VGA cables are quite rare. Let's see if we can get VGA or parallel from old printers. Yeah, look at that. $5 for VGA cable. Oh, DVI. Yes, even better. Okay, LPT, PAN. Yeah, no. Yeah, there is nothing. No. Kabel. And then we need to check eBay. I have one downstairs. RJ. Druckerkabel. Pff. But they are too big. Look at the USB. What? What are you talking about? When? Live. When? Don't tell me. Don't scare me. Where is there is there is no holiday. Where is holiday? No announcement of holidays. Where is the holiday announcement? Yeah. Yeah, we need to check if there is like, but I expect at 4 o'clock at the earliest the next step in my production. Yeah, still needs to data preparation. They still need to figure out with the 512 MCUs how to orient them correctly. Yeah, 19th is tomorrow. You know that. Tomorrow is the 19th. Today, like, uh, life and cycling. This is like in 1.5 hours we have. In China, it's China. It's already the 19th. I can still. Oh wait. Maybe it's no. Where's the smell coming from? Smoldering PC. If I go offline, my PC burned. There is no holidays. Oh, they start Fab at night, so my boards won't be started until tomorrow evening. Or which night? Like your night or like our night or their night? because they start working at 4 o'clock. That's how I see like the earliest reaction from JC when I like use servers or whatever. 25 pins, yeah, that's what we want. We just need more of those D-sub cables. Here. Nice. Ah, right, okay, so probably I need to, when they process my data, I need to check, figure it out during the day, and then it will be start produce. No, it's not the new electronic smell. It smells uh, a, like a cap, electrolyte from a broken cap or something. Something more like that scent. Not like burnt electronics, but you know how that smells? Like the like PCBs. It smells like PCBs. Like fresh, uncoated PCBs. More like that. So probably if there is something going on, yeah, whatever. You will know if I'm still there. No, there is nothing below. I just I just remove. It's everything is gone there. No, there is nothing there. That could. There is not even electricity in that room. Just backlog. Oh wow, it's congested. But that means that if you place an order like I did for purple PCBs, it will probably be manufactured more quickly than usually because then they get like the panels full quickly. I don't know. You might be lucky in the end if you're towards the end of. I mean, you're waiting for your boards forever now. Are you? Or did you just order? Differential pair SATA. Not sure if I should go with that. Chip select could be used now. Well, we would need to test that. I need to get a SATA cable and cut it open and test if we can. Oh no, I am 6 layers, my friend. 6 layers with impedance match stack up. That's not ANIC, of course, automatically if you go 6 layers. So there is no quick solution. It's probably 5 days. Oh, do you have a link to one of your products? Live, you will get, wait, you will get moderator, right? You can paste the link to your creations. I would be interested what you made. Threadripper, my aimbot with 14 layers. Yeah, drop a link. Oh, I'd be interested. I'm getting tired, my friends. We didn't solve the issues with. I mean, if I need to figure out the parallel. But if I can't get the parallel cable, we still didn't figure out. Spool and Spur. Tiny race IRX transponder. What is iRace? Ah. Okay. So there is a MOSFET driver for. Is this an infrared LED like that? Are you using it also to receive? Yeah, too. Looks cool. I have no clue what it does, except it uses IR. All right, I need to find. Ah, RC. All right. Here we go. High speed ultra ATA. Oh, look at that. 40 pin. One ultra ATA. So we're looking for ultra ATA basically. You can get one for 30. That's all right. Look at that. We need 64, so under $100 we get. I don't want to sign in now. I can't even click anymore because it's hidden behind. Oh, this is so annoying. And I don't want to check out and I don't want to log in. All right. How do I get not the welcome deal? I just want. Why am I locked out? I want just let me log in. No. I have like 16 parallel lines that I want to. I want 2 pairs of 16 parallel lines. Just provide a solution to transfer that. Oh no, they are keyed. I don't like that key because you can't use like basic header for that. That's ass. Oh, look at that. They're this color. Oh, yes, that's what I. No, this is not acceptable. This is not what I want. Yeah, no. This is not a welcome deal. This is no good. Oh, this is the SCSI cable. 40 pin. Oh, really? That's why it's so dangerous to use that, because there are some standards and I don't know which pin is connected to the grounds in between the other lines. So look at that, 99 cents. How long? 36 centimeters, almost too short. Yeah, it's quite short. That's like this long. Hey Dave Odessa, how are you? Huh. There are longer ones. Look at that. That one is longer. How long is this? They don't specify. No, not description. 60 centimeters. Our cable about 43. Yeah. Oh, look at that. Someone is not happy with what they received. Look how colorful they are. Nice. No, they're 40 on 80. 80 strands of and 40 pins, while one pin is used as key. Or what do you mean? Yeah. Like this one here. This one is a little bit too short. Super thin, these wires. So they put ground, like I'm wondering how that works within the connector. Look at how dense this is. And they put like ground in between every single line there is ground, and it's taken from like the first pin, or I don't know, last pin. This is not, can't find like specific data. I would need like to crack it open to see how it's done actually, because I can't be sure if I want to, like, which pins I can even use. Yeah, but regarding the price, oh, 75 centimeters, quite pricey though. Oh, look at that. That one has 50 pin STSI. Oh. Yeah, but that there is no ground in between the lines. All right, so oh, what is this? Screen cable. This is what we were talking about. Oh, yes. Is this a high density? How many pins are those? Very bad reviews, huh? Single, not double connections? What? kind of connector is that? 40, 51 pin. I could use basically a flat flex. Can we do like a flags with ground plane? That would be the best. Okay, maybe we'll find out. Expert exchange. Signal integrity centimeter. That sounds like 50 kilohertz. Okay. Almost what? We didn't do anything productive except for research here. Like, what is a common... World's biggest opto-isolator. Or like most channels. Highest channel count. Look at that. That is cheap. 50 pieces. Yeah, alright. That's not many strands though. What's a quite common... Okay. I'm wondering, I mean, we could measure that even. You know what? I take this cable, but it doesn't look like it's a keyed SATA cable, so it might be just a ribbon cable with as many pins. I can smell it again. It's coming from somewhere here. Maybe it's just a little bit. Did I push something over that spills? Like this glue. It smells like glue almost. So weird. I hope I don't burn down the house. Some weird stuff here. Okay. Where are my long pins? Okay, this could be interesting. Ah, okay. Yeah, this is what I want to see, like super old page. Uh-huh. Slave and gray. So these two are only, so one of those depending on which one I'm connecting to, and internal connections. These are the ones, these are the external ones. Oh wait, these are the ones that are not the wires that are not, okay. Here, 1, 2, there's another one. Oh. This is the cable, but alright. Let me measure that. I will just plug in something here. What should be connected? Our fresh meter. Just put the header here. Okay, so this is not the right row. Remove that first. Wait, it's a second maybe. Okay, I don't know. Aha! Wait. Okay, I got one here. That was 24, 26, 30, 40. It's weird. I will find the source of this smell. I can tell you that. All right. At least I can test it with this cable here. Even though it's not a keyed one. Thank you, Sonic, for that info here. I can test. Nope. Okay, last thing we have calculated the count of power that we can have here, 4, like this. We can have 4 connectors here, 150 watts per connector, and 1, 2, 3, 4, 5. That's like 4, 4, Was the one that you shared was 3 connectors? Was it 4? Did we find a cable? I need to check all my links. If it's only a 4 connector thing, I mean we can distribute. Oh, all right. That's not much. That's not a lot. 1 point. Yeah, that's 30 watts then. How many pins? What is the pin configuration for that? I don't think I will need this SATA power things. I can use them to basically power everything else. Because I have like now, I have. Oh yeah. Oh yes, on SATA, but on the 6-pin connector on the other side of the PSU, there's probably 2 grounds and like 3 voltages, because we have 5 pins. All right, one thing, I wanted to calculate. Oh, I need to take a leak. We have that many amps. Okay, that's not what's important. We can have 450 watts, 150 per. That's that 8-pin connector, 150 at 12 volts. Oh, modular PSU connectors aren't standard. What? Are you kidding me? But yeah, this 8 pins are not the 6 pins. I mean, okay. All right. We have 6 times connectors. We have 8-pin connectors. It's 12 volts. 12 volts, 150. That's watts. Volts. Power. No, wait, this is power. Huh? Yeah, I need to go to bed. My dudes. This is getting... No. Yeah, I need to go to bed, definitely. Okay, 12 amp, 12.5 amps. Count, we have that. We have 6. Yeah, that times that. No. Yeah, let's do that. Total power. Then we have the, what, I forgot the name of this connector again. High V 12 high voltage, blah 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 blah. We have 600 watts. That also 12 volts, amps. It's calculated 50 amps. Count, we have 4. That's that. So what happens if we don't use it, 12 HV split into two-way. If we use the lines, that's basically that will be 150 then. And then we have also 12 volts. Wait, I don't need the 12 volts. 150, 12, and then we have the count is 8 then. So yeah, that's not enough. We can't carry enough current if we two-way split the high power thingies. You found the three-way connectors. So three-way split will be yes, 300. Yeah, that's why we have 8 in the count in the total. So basically 150 times 8, not 4, and it will be 12. Not good, because the total of that and that is only 2.7. I mean, they have some tolerance, and probably we don't need more than that, but that's also, yeah, that's 18 lines. Oh, that's so stupid. But I probably don't want to run it more than 2.7. What's our anyone remembers what consumption we had on the thing last time? I think we had like the power, the 10 milliamps wasn't like really right. It was way lower than that, but I think we have like losses and conversion and then everything. It will be really close. We can't draw 150 amps from. I need to take a leak. I don't know. You know what, pips? I will close the stream for today. It's a puzzle. Everything is puzzle. Too many things. But the decisions that I think I make today is that the parallel lines, I don't think I will be able to put like this ultra eta connectors on the back. It's probably too much. It's like too much cables as well. I might test the SATA stuff for the if that works well, but the differential pair, I don't know. Maybe HDMI. We have enough in it. Oh yeah, ITT. Good night too. I will put a footprint for the Tang Nano. Yeah, we need to go step by step, and the first thing that I need to take care about is to get like enough connections for power, and the SATA, no, the SPI out, and that's all. The parallel lines, we don't need to care about that too much for now. We just need to get it going, and then we can care if we want to improve the performance later. Good night, everyone. Bye bye. Have a nice sleep. Yes, please. but I need to run. Please drop it here. I will grab it from here. Bye bye everyone. Stop.